This is Honors Geometry Lesson 10.6, Segment Lengths and Circles. So we've been talking about the measure of arcs and the measure of angles, but we haven't talked about the length of segments. So there's going to be three new rules we're going to talk about. The first one is when you have two chords intersecting in a circle. The secret with that is if you have two chords intersect in the interior of a circle, then the product of the lengths of the segment of one chord is equal to the product of the lengths of the segment of the other chord. And what does that mean? Let me show you. So say you know this segment is 2 units, this segment is 6 units, this segment is 3 units, and we're looking for this one. We know that this times this, the 2 times the 6, the two segments or two pieces of this chord are equal to the product of the two pieces of this chord. So we get 12 equals 3x, divide each side by 3. You'll see that x equals 4. Let's practice a few. Oh, I think we used the same one. We have 3 times x, the product means multiplication, equals 4 times 6. So we have 3x equals 24. Divide each side by 3. It looks like x is going to be 8 units long. Okay, one more. 4 times x equals 5 times 8. We get 4x equals 40, or x equals 10. Let's bump it up a little bit. Let's throw an expression in there. I just want to warn you, make sure when you do this, you distribute. So I'm going to say 9 times the quantity x minus 3 equals 10 times 18. Or we get 9x minus 27 equals 180. We're going to add 27 to both sides, so we get 9x equals 207. We're going to divide each side by 9. What's that give us? 207 divided by 9. And it looks like x is going to be 23 in this case. Okay. Let's keep going. All right, here's another circumstance. That was 2 chords. Now we're going to deal with a tangent and a secant. So if you have a secant, you know you have an interior part and an exterior part. It says a secant segment is a segment that contains a chord of a circle, that's the interior part, and has exactly one endpoint outside of the circle. The part of the secant that is outside of the circle is called the exterior segment. Okay? Inside is actually the chord, or the interior, and then the exterior. All right. If we have 2 secant segments, if 2 secant segments share the same endpoint outside of a circle, then the product of the lengths of one secant segment and its exterior, segment equals the product of the length of the other segment and its exterior segment. Okay, so let's take a look at that. What they're saying is the outside times the whole thing equals the outside times the whole thing. Makes a little more sense when we put some numbers on that. So we say the exterior segment times the whole thing. So if the inside is x and the outside is 5, the whole thing is x plus 5. We're going to multiply that. And the outside is 6 times the whole thing is going to give us 10. Let's distribute that 5. So we get 5x plus 25 equals 60. Subtract 25 from each side. It's going to give us 45. Whoops, no, wait, 35. Divide by 5, it looks like x is going to be 7. All right. Okay, outside piece, which is 10, times the whole thing, which is 24, equals the outside piece, which is 8, This time they're telling us the whole thing is x, and that's perfectly fine. Let's multiply that. We get 240 equals 8x. Divide each side by 8. It looks like x is going to be 30. All right. And that's more of the same. All right. If you get an x on the outside, I just want to give you a little heads up. There's one on Schoology like this, so let's look at that. It's outside piece, which is 5, times the whole thing, which is 12, equals the outside piece, which is x, which is x, times the whole thing, which would be x plus 4. So we get, that's 60 equals, we're going to distribute this x. I'm going to bring this 60 to the other side, subtract it from both sides. You can see what we have here. We have a quadratic. We have an exponent of 2. We're going to factor that. So we're looking for two numbers that when we multiply them, we get 60. When we subtract them, we get positive 4. So if you want to just start at the beginning, 1 times 60, 2 times 30, 3 times 15, 4 times 10, 5 times 12. Let's see, we're looking for a difference of 4. And how about 6 times 10? Boom, there we have it. 6 times 10 has a difference of 4. When we combine like terms, we want the 4 to be positive, so let's make that a plus 10, a minus 6. One at a time, we set them equal to 0. So I have x plus 10 equals 0. Therefore, x equals negative 10, and x minus 6 equals 0, and therefore add 6 to both sides, x equals 6. We know we can't have a segment length that's negative 10 units, so we just disregard that answer, and our answer is going to be x equals 6. All right, one more rule. This time we have a tangent segment and a secant segment. It says if a secant segment and a tangent segment share an endpoint outside the circle, then the product again, we're going to multiply again, no surprise, of the lengths of the secant segment and its external segment, so again that's the outside times the whole thing, equals this one's different, square of the length of the tangent segment. Okay, so we're still going to do the outside times the whole thing, but this time it's equal to the tangent squared. Okay, so let's practice a couple. All right, so I'm just going to call this x. They're looking for the length of PQ. So it's outside, which is 6, times the whole thing, which is 6 plus x, equals tangent squared this time. Distribute my 6. Equals 144. Let's subtract 36 from each side. So I get 6x equals 108. Divide each side by 6. And I get x equals 18. All right, there we go. We'll try one more together. It's outside piece times the whole thing equals tangent squared. Again, I'm just going to call that x to make it easier. So outside piece, which is 14, that's called the external segment, times the whole thing, the secant segment, would be 26, equals tangent squared. 14 times 26 equals 364. Equals x squared. We know to get rid of a square, the opposite of squaring something is square rooting, so we're going to square root both sides. And that gives us, and it says round to the nearest tenth. I got 19.07, so we're going to call that 19.1. All right, please try the practice problems. Let me know if you have any questions. Thank you.